All right, so Metro Media Cable has provided service to a customer whose house is located 2 miles from the road, along which the cable is buried, along here. And the nearest connection box is 5 miles down the road. So they gave us a nice picture here. Okay, what I want to know is, it's $500 per mile along the road and $700 per mile off the road, which would be this part here. And I want to know a model expresses the whole cost C of installation as a function of distance in miles from the connection box to the point where the cable is going to be to the point where the cable goes off the road goes to the house. We want this whole thing here. So what I want to know is, what's the cost to run the wire from here up to here? What is it going to be? So what I know is that if this distance is x here, this distance here is 5 minus x. Okay? And this distance is 2, so I have a nice little triangle, and I can find this distance here. Remember, it's 5 minus x squared plus 2 squared, I'll call this d, is d squared, but using my Pythagorean theorem. This is set 2. This is variable where they end up going off the road, and so it's 5 minus x. So my distance, this distance here, the distance when I go off the road is the square root of 4 plus 5 minus x squared. And what I know is the cost is 500 times this x. 500 times the x is how long it is along the road, and this cost is 700 d. So let's simplify this d. This is 25 minus 10x plus x squared, and I have 4 plus that. So my d is 29 minus 10x plus x squared. That's my d. So now I know my whole cost is 500x plus 700 times this d. And what's my domain? Well, my x can go anywhere from 0 to 5, right? I can either go all along the road to here and then go up, or I could just start here and go straight across to the house. So there's my domain. So the first question after I found my function is, what's the cost if x is 1 mile? So C of 1 is 500 times 1 plus 700 times 29 minus 10 times 1 plus 1 squared. And go ahead, put that in your calculator and find the value. And that equals 3630.5. Okay, what if it's 3 miles? Same thing. Plug in 3, 500 times 3 plus 700, the square root of 29 minus 10 times 3 plus 3 squared. And that equals 3,479.90, I think. Now it says to go ahead and graph your function and use a trace to see how the cost C varies as x changes from 0 to 5, and then where is x, what minimizes the cost. So go ahead to your calculator and put the graph in and graph it. So you should have this, enter it. Can't really see it in what they give you, right? So what we're going to have to do is we're going to have to go to the menu. I'm going to go zoom, and let's do a zoom fit. All right, there we go. So we also actually can go back to the menu, and we can go to our window, and let's set our settings, right? We want to go from X is from 0 to 5 because that's our domain, right? And maybe we want to make our Y a little bit smaller then. So let's go back to our menu and our window zoom and window settings, and let's make our Y max maybe 5,000. All right, can we see it a little bit better? So now let's go to trace, and let's trace, and we can just trace along, see what happens to the cost. As you get closer to the box and more off-road, the cost gets higher. You get to a certain point where you get to a minimum, and then it goes up again. So let's find our minimum. And it's when it's about 2.96 miles from the box. And that's how you solve that problem.